Welcome, everybody. So my name is Jason Gillam, and today we are going to be covering improving application security with the PCI Software Security Framework. That's a lot of words, but we'll break it down and let you know what we're really talking about here, what we're really thinking. With me today, I have Mick Whitehorn Gillam, and yes, he is my brother. Some people may be asking or wondering. And we have Nathan Sweaney.
I'm not his brother.
Nathan's not my brother.
As far as we know,
at least not biologically. So, all right. Without further ado, I got
to redirect.
Okay, so let's start this off. So why do we want to talk about the application security with the PCI security framework? Like, why is that important? And I guess a tack-on question to this is, why are we talking about PCI at all? Like this should be security frameworks in general for applications. We really want to be thinking about them more globally, right? So why?
Yeah. So security programs, right? There are a lot of organizations in a lot of different stages with the maturity of security programs, right? We've worked with large, well-established organizations that feel like they're building it from the ground up. We've worked with startups that have very mature security programs very quickly because they've bought into that from go. So a lot of people went into a lot of different places, and it ends up being important in order, especially when you have a compliance requirements in order to meet those programs really help provide structure, right?
I agree with that in principle, like that from what you're saying, but I think there's something to be said about so the PCI Software Security Framework is my understanding, and I'll leave it to Nathan to correct me on this because he's actually done the deepest digging into PCI stuff of the three of us. But the Software Security Framework was an evolution from PCI DSS, right?
Mm-hmm.
That's where its roots are. That's where it came from.
Yep. And
although PCI DSS was initially intended to be used for protecting cardholder data, it has grown as a popular template across many different industries. So it's just like, this is how you should do software security in general, not just for your payment card information.
Yeah, and we noticed that during kickoff calls for testing engagements as well. You get a lead developer or senior engineer on there who maybe this particular app doesn't have any kind of payment requirements, but because they went through training, because they've been through pen tests before, they're better prepared, and generally their app is as well.
I think at a lower level too, there's a process of we secure things that present the most risk.
Yep.
And when the security industry was first kind of getting started, that was really focused around network stuff. And there's kind of cycles, I guess it feels like through the last couple of decades of security, and we're at a point where AppSec is kind of at the height of that cycle right now, right? Where we've secured a lot of other stuff, and applications for the last 5 or 10 years have been one of the next biggest risk, and so there's a lot of effort push there. I think we're at a point where users and social engineering is maybe kind of coming back. Like we're doing better with AppSec. And I think we're going to see more social engineering coming to the height of that. I don't know where we are in there. That might make an interesting talk sometime. Just the revolution of security controls around different parts of security.
Yeah, and how the different technologies that we're using to build stuff shape that as well.
Yeah. But I think too, it's applications are everywhere. I mean, whether it's our mobile apps on our devices and the Echo here on my desk that I'm not going to say the A word, but you know what I mean? It's our computers, it's our cars, it's what was it the other day? A friend was asking if I thought they were qualified to apply for a job that Like they didn't know anything about automotive stuff, but they knew a lot about AppSec. And the job posting was for an application security, but they wanted somebody that knew like automobile, not the CAN bus stuff, but like the entertainment system stuff like that.
Yeah.
It was with NVIDIA, which I didn't even know NVIDIA did automotive stuff, but apparently that's really big. So it's stuff's everywhere, and security's hard.
Well, and there's been an explosion across it as well, because traditional applications, often it was, this 3-tier architecture. You have your client side, your server side, and some data, or maybe there's a middleware in there. Like, so maybe there could be more than 3 tiers, but it was, very distinct tiers. And now when we look at the way applications are built today, they're built out of a whole bunch of microservices, and each separate one of those could be considered its own application.
Your back-end architecture looks like someone sneezed on the whiteboard.
Yeah, pretty much. Yeah.
Well, and then you include other things like, edge computing versus cloud computing, or maybe a combination of both. And then you've got machine learning stuff pulling in stuff and all these third-party components and third-party services. And Jason, you and I were complaining earlier about, you open a web page and an app, and it starts to do something, and you click on something, and then it finishes loading, and what you clicked on is not what you intended to click on. So much junk happening.
I hate it when that happens. Things change under your mouse before.
As you're clicking. Yeah.
The summary, I think, is applications are more and more complicated, and so security is harder. And I think is it fair to say frameworks kind of give us a standardized way to approach that?
Frameworks like this one, and my caution there is that it's an overloaded term in the space, right?
That's true.
Software frameworks and stuff as well.
Yeah, so. Namespace collision.
Yep.
I got out of development before frameworks became a thing. So, all right. Well, let's talk a little bit. Jason hinted a little bit about the PCI side. So
let's move on to the next slide.
There's a couple of components when people, and this is, I'm going to cover PCI in like 60 seconds. So timing, let's see if we do this. The PCI DSS started out as the data security standard for card brands to push down security requirements to merchants. That came out in 2004. A couple years later, 4 years, I guess, the PA-DSS, which was the payment application DSS, came out. And that was the first application security standard put out. And it was specifically about payment applications, point of sale systems, the application where you actually swipe your credit card and all that. 2009, we saw the PTS standard, which was like PIN. I don't know why they changed the naming format, but they went from something DSS, PTS. But, and then from there, this is the current, this is actually even already outdated. I think they're up to 17 or 18 now, but what you see is all of these different standards that have been developed by the PCI Standards Council. And across the top there, you see the data security standard as the overarching, like that's the main standard. And then everything else adds to it. And you see the relationships of the different entities, from the issuer on the left side of the cardholder's bank to the issuer on the right side, the cardholder's bank, and then the whole process of relationship. And you'll notice the vast majority of the standards are there between the merchant or the service provider, whoever that is that's taking the credit card, and the acquirer. We sometimes call that the processor. And so all of these other standards are designed to basically fit into that contractual relationship. So that's like I said, PCI in 60 seconds to kind of understand the nature and the relationship of these standards. But it's important to understand, because I mentioned contractual relationship. PCI is different than the vast majority of other standards, and we'll talk about a few of those a little bit later. Most other standards are voluntary, they're optional, or maybe they're government regulations, whatever. PCI is a contractual requirement between the merchant and the acquiring bank. And so when the merchant says, hey, I want to take credit cards, the acquirer says, okay, that's great. Here, you pay us this much, we'll do this for you. Oh, by the way, you have to follow all these standards. And so they have a contractual obligation to do that. That's where what originally was the payment application data security standard came in. That's since been replaced. I think 2018, 2019, that was kind of sunsetted. And we started hearing about the software security framework. And then now that's basically replaced it. But how was that? Did I hit my 60-second mark?
No,
I think you went a little
way over.
I think my initial summary was 60 seconds, and then I can't stop expanding. But
I have that problem.
Yeah. I'll throw out a quick plug there. If you're interested and want to know a little bit more context around all this, I actually have a 4-hour pay what you can course with Anti-Siphon that kind of deep dives a little bit more into what PCI is and understanding these standards and all of the other stuff. But we're not going to get into all that today. You can go take that another time. So, Mick, you want to summarize the structure of the SSF, and then we can kind of talk through the individual components?
Yeah. Okay. So, I mean, there are parts to it.
There's only two main parts, though, right?
Yeah. Well, yes, and then they have parts within.
There's
the parts.
breakdowns from there, but yeah.
Well, it's actually two standards. I guess we should start with there. Maybe like a lot of people think SSF as a standard, and PCI kind of.
It's not. They call it a framework because it's the collection of both standards.
and so yeah. On the left there, you've got core requirements for the software requirements and assessment procedures. Because everywhere where they've got control objectives, they've got how to assess it as well, obviously, because that's part of the process for validating. So core requirements, below that modules, those drill into all kind of more technical guidance, I would say. And then the nice thing, so the 1.2 version of that document, which I believe is current, it has 3 modules listed there. But I think there's a potential that as needed, they could create new modules. They may break out parts of the existing ones too. We don't know exactly, but it I like modular things, right? It's like a plug-in framework for your framework. So it can expand as needed to. We start seeing, for example, a bunch of large language models integrated into applications, or maybe a module for that.
Sure, yeah. Right. That's a good idea. Yeah, I think we'll see that. I'll be surprised if we don't see. I mean, just the way PCI works, because of the governing body and how that all happens. They'll be like, somebody will suggest something. They'll create a what do you call it?
Some sort of guidance on it.
Well, it's a special interest group.
Yeah.
So among the participating organizations, they'll create a special interest group to discuss it. And then a lot of times they'll put out like a guidance document that says, here's how we think this should be handled. And then over time that will be rolled into an actual standard.
Yeah.
So
hey, one thing I want to, before we get too far into the depth here, just as a point of clarification, I'll read a sentence from the introduction of the software requirements and assessment procedures.
Uh-huh.
It says, this document, the payment card industry's secure software requirements and assessment procedures, and then in brackets it says, hereafter referred to as the PCI Secure Software Standard. So it actually has 2 names. It's also the Secure Software Standard, not to be confused with the Secure Software Lifecycle Standard, which is
totally different.
Yeah, and somewhere along the way, I think it actually went through some kind of name change where it was initially called the PCI Secure Software Standard. I think I could be wrong on this.
Yeah,
but and then they switched it to the software requirements and assessment procedures.
They might have intended it as one document in the first place and then split it before publication.
Yeah. So that's a good point, because Mick kind of summarized the left side. The right side is the separate standard that Jason's talking about, which is the secure software lifecycle, right?
Yeah.
So like, okay, quick poll. What does SDLC mean? What do you guys think when you think SDLC?
Software development lifecycle.
I mean, yeah,
or system development lifecycle.
I was gonna say, yeah. I learned system design lifecycle, but system development, software design. And now you have like secure development lifecycle, secure. There's all these. Everybody's got different terms talking about name collisions there, but I mean, they're really not that different, right? It's basically the process that we use to make applications.
It's kind of like the, in a way, kind of like how DevOps, well, you got dev, you got ops, you got DevOps, then you throw DevSecOps, then you throw, I don't know, how many other little short things that you can chain together in there to make a remix essentially of the same thing plus.
Yeah.
Right. So on the left side, software requirements and assessment procedures, we have here's the basic security, good security, hygiene types of things that you should be doing, like minimizing the attack surface is the first one that we've listed here, right? So
love that plan.
That stuff. And then on the right hand side is a lot more of, okay, well, how do you govern all of this?
Yeah. How do you build out the program to do the stuff on the left?
Yeah.
Which I think one of the, and we'll talk about these in a little bit more detail in a minute, but I think one of the funniest things about it is one of the software requirements is that you manage your secure software lifecycle. So one of the requirements is that you have the program to teach you how to manage the security in the first place.
Yes.
But when it comes time to evaluate whether you're doing that, there's going to be a control objective and an assessment of, are you doing that? How are you doing that?
Yeah, it's kind of recursive, I guess, like that, right?
Yeah.
So, anything else to say there before we move on?
No.
Yeah, not really about the content itself, except that I think they've done a good job of presenting at least a plan or a roadmap for how do you actually get there, and that's kind of what, going back to what I was saying before, is that this isn't just for payment card industry situations. Like this works for any secure software lifecycle that you're trying to build. Like, so if you're hey, I need to build an application security program, how do I do it? Here's a good place to start.
Yeah, it's kind of like when we have a software framework that we refer to as batteries included. It's got all the parts that you need. You don't have to cobble together different bits. A lot of these are things that people need to build secure software, but in the past, they may have had to pull together either homebrewed stuff or cobbled together bits of other things that are out there.
Yeah. Well, and that's a good jumping off point, because I don't think we really decided where to talk about this. I kind of have the sneaking suspicion, and Mick alluded to this kind of in the intro. I think we're going to see some of this stuff applied outside of PCI requirements, right? So if you have, in fact, I've had companies say, like, hey, where do we get started with, application security? What framework should we use? What, standards should we use? Whatever. The SSF is a great place if you don't have any idea where to start, to say, here's the process. And if you don't have to worry about the compliance side of it and the auditing side of it and all that, even better. But I think it's just general good guidance, no matter, what type of application you're building.
Yeah. Everybody's got something to secure.
Yeah.
So.
Are there other tools out there for the secure lifecycle side of it? Like, I know Microsoft put out some stuff.
Microsoft's got a lot. OWASP does as well.
Yeah, I was going to say OWASP is the main place to look, I think, for alternatives.
Gotcha.
That's where I would look anyway.
Yeah. All right. Next slide. So this is just a quick example, but I thought it would be good for folks that haven't looked at this before, or if you've never seen a PCI standard document. This is pretty typical of the way PCI has started doing things. It didn't used to be. It used to just be really simple, like, here's the requirement. But what you see on this is, what is it, 5.2? I got to make that bigger so I can see it. Mm-hmm. 5.2 is the requirement here. So let's go back to that previous page. Nope, I don't have the numbers there. Which one is 5.2? 5 is the category is authentication and access control.
Yeah.
So under authentication and access control, you have a requirement that access to critical assets requires unique identification. Okay, that's pretty straightforward. But of course, then that's going to create all kinds of, okay, well, what is a critical asset? How do you decide that? What do you mean by unique identification? And so then we have two other components that or parts of this page that are useful. I'm going to jump over and talk about the right side first, because I find it more useful a lot of times. The guidance is basically sometimes it's a paragraph, sometimes it's 4 or 5 paragraphs that explains what the standard makers were thinking. Right, here's the general idea of why this is a requirement and what you should be looking at. So there, that says the software should not require the use of any group, shared, or generic accounts. These things make it more difficult to determine which individuals execute specific actions, blah, 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 blah. Right. So they're saying, hey, this is the intent of this, is that everybody has unique identification, not a shared account, a group account, or whatever.
Right.
Which
so
that's all part of
behind non-repudiation right there. It's what
exactly.
Yeah.
Yep.
Exactly. You want to explain what non-repudiation is in case people don't have a clue?
I always struggle with how to put it into other words.
Yeah, I know.
I've used non-repudiation because that is the word that means what we need it to mean. But basically, it's it's the concept of being able to ensure that if an identity performs something or claims to have performed something, that they can't say they didn't, or that it's possible for somebody else to have done that thing, whatever the thing is, like accessing a document. So if we have good non-repudiation controls in place, and I access a document and there's a log that says that I accessed that document, I can't then say, oh, no, that wasn't me. That could have been somebody else. It might have been Nathan who accessed that document, not me. And that would be the principle of non. So that's the best way I can think of explaining it. Maybe you got a better way.
It's like attribution.
Yeah. No, that's I think there's the other side of it too. You can't accuse me of doing something if my account didn't do it, right? If there's a group password and we all have it, you could accuse me and I can't prove I didn't. Or we could all say it wasn't me and you can't prove it was, right? So it kind of comes from both sides there.
Yeah, I don't really think about it that way, but it's a good point.
Yeah. We had, it's funny, Jason and Eric and I just literally today, we're talking about a situation with a client where they have employees that they believe performed some malicious activity and they're trying to verify whether it could have happened or not. And it's like, well, all of your IT people have this level of permission. So, or at least capabilities of having this permission. How do you know? You can't prove they did or they didn't because we just don't know.
That happens quite often. That's one of the main things that we bring up on pen tests or architecture reviews for companies that haven't gone through a lot of that before, right? It's a very common situation.
Yep.
So, but it's also one of the first things we say, hey, you need to fix this.
Yeah.
And it's not that hard to fix. It does take some time, a little bit of planning to do it, but it's not technically complex in most cases.
Yeah. The middle column there, excuse me, I got a little bit of a throat tickle. The middle column is, they call it test requirements, but basically this is, because this is a compliance document, organizations that make applications that are required to comply with this, they have to have an assessor come and validate that software, validate that it really does meet the standard.
Somebody in an auditor type role, basically.
Exactly.
Come in. And...
There's a term for it. I think it's SSF assessor, but there's actually two separate roles. You have to go through training to be
yeah, that's right. Yeah.
Secure software requirement assessor and the secure lifecycle assessor, whatever.
We don't know. We don't do those things. We know some people who do, though.
Yep. Yeah, exactly. But so what they do is they go through the middle and they basically say, all right, here's all the different particular things that could come up, nuance situations. The assessor shall examine evidence and test the software to confirm that it's implemented correctly. It talks a little bit about APIs, right? APIs is one of those places where sometimes authentication is handled a little bit differently. How do you have unique credentials for an API and what does that look like? 5.2.c talks about non-console access, etc. You get the idea. Mm-hmm. So all of the requirements in the secure software framework, I start to say SSF. I don't even know what to call this thing anymore. In this document, basically go to this level of detail, and so we're not gonna get into all of that in this webinar, but it's good to kind of understand the context of what you're looking at.
And this is a deeper dive into some of the core requirements. I guess it's all of them, right?
Yeah.
Yeah. Looks like it.
This is just the core requirements. That's separate than the modules that we talked about.
Yeah. Yep. And all of these should be, oh yeah, that makes sense.
I found myself doing that a lot when reviewing this stuff.
Yeah, that makes sense. We should be doing that.
Of course you would do that. Who wouldn't do that?
Yeah. I like the categories that I feel like they do a really good job of saying like, hey, minimizing the attack surface. Here's the intent for that. Like, here are the ways that we're doing that. Software protection mechanisms. I did think it was interesting. They have critical asset identification and then critical asset protection. I'm sure there were some committee meetings and arguments about, do we separate these? Are these the same thing? What does this look like?
Yeah, I could definitely see that happening.
Are there any in there that are surprising?
See, you're asking the wrong people.
That's true. That's true. For us, we read through this and we're like,
we do a lot of this day in and day out. It's like, no, all of this makes sense to me.
Yeah.
I totally get it. But I mean, yeah.
I don't see. I don't know. To me, it's a little weird that I guess it's under threat and vulnerability management. I guess because they separated identification and protection for the critical assets, I thought remediation would be split out into a separate one. But
interesting. See, I think I would consider remediation maybe under the threat and vulnerability management side.
Yeah,
because that's like so many people, especially on the network side, they're like, oh yeah, we do vulnerability management. We run Nessus. Yeah, but what do you do after that?
Yeah.
Well, we run Nessus again. Like, yeah, you're running Nessus every week and nobody looks at the findings or does anything with them. That's not vulnerability management. That's vulnerability scanning.
Yes.
vulnerability identification.
Yeah.
Yeah. Which is an important step.
Sure.
You know, you can't fix what you don't know about, but it doesn't get you there, right? So
yeah.
No, all of these do, and I like the way that they've broken them into categories as well. So
yeah,
secure software operations looks a little thin compared to the other ones. Yeah, just because it's 2 points and the others are 3 or 4.
Yeah,
I agree, but I also think that a reason why that's thin is because they have the whole other standard for this life cycle, which is likely going to cover a lot more of the operations, because that's going to be the governance behind things.
Yeah.
So these are
some of it.
Yeah.
Yeah.
That's my thought on why it's a bit thin, because this is talking about pretty specific set of activities, right?
Yeah.
We're doing activity tracking in the software, and then we're doing attack detection in the software. So it's, what does the software do?
Yeah, I think too, this is even though they call it operations, we go to operation stuff, right? We go through, hey, it's in production, it's being used. Like, how do we manage it, maintain it? That's what we think of as operations.
Yeah.
But I think this is intended to be focused on the development side.
This is logging and monitoring as well.
This is building the capabilities for logging and monitoring
into the software.
Right.
Yeah. Which, when we discuss software with clients, sometimes their software, it is often a thing that I think has come out several times in architecture reviews lately, where it's been, we know we have a gap here. That's
the main time and I actually bring up a really good point. So a lot of what we do is pen tests. Sometimes we do arc reviews. There's a parallel on this one to the OWASP top 10. They've forever had insufficient logging and monitoring, which is the one thing that we can't really test most of the time. Like, usually we don't have access to test that when we're doing a pen test.
Yeah.
I gave a talk several years ago that I can't even remember where it was at now, but it was for actually I do remember, it was a developer conference here in Oklahoma. And it was, what I was talking about is how do you do security logging? What does that even look like? And I think that, like, the activity tracking they're talking there, what types of activities should be logged, how much is too much, what types of things shouldn't be logged, right? Because sensitive data of any kind should never be logged. There's a lot of considerations there of the types of activities you want to make sure you see. And some of that is for just to make sure that the application is working correctly, right? The operation side of it, you want to be able to identify potential, flaws or mistakes or things before it becomes a big problem. But some of it too is after there has been a problem, you need to be able to go back and do that incident response process and figure out, okay, what actually did happen.
Yeah. And for certain types of attack detection as well, establishing some sort of baseline of what normal looks like ends up being critical.
Yeah. That's what, if somebody says, well, we've had, 5,000 failed login attempts today. So
is that normal?
Is normal 5 to 10,000 or is normal 1? Like,
yeah. How busy is this app?
Yeah, exactly. If you don't have a baseline, you can't do anything.
Yeah. No, it puts you later responding usually.
I think the vendor implementation guidance I thought was interesting on the lifecycle management software vendor implementation guidance, dealing with third parties and all that. I don't remember if that included the like third party libraries and components and stuff like that, or if that was covered somewhere else. But I don't remember seeing that covered very deeply in the standard. I don't know if either of you guys.
Where did I see that? No, it is module C deals with
that's right.
a lot of it.
That's right. All right. Well, are we ready to move on to that?
Yeah, let's skip over to the next slide because I think
there it is.
There it is.
Yeah, there we go.
So we mentioned the core requirements. Basically, the standard is designed of like, hey, here are the main components. Those last 12 are things that should affect pretty much every application. But then there are other components that affect some applications, right? And so the structure of the way they've done this is, you have to comply with 1 through 12, and then if these others are relevant to you, then you have to comply to them.
Yeah, yeah. And so module A in this case is referring to cardholder accounts, not user accounts specifically. Although there's often a one-to-one relationship.
Yeah, and then I'm going blank on what terminal software is.
I think it's point of sale, isn't it?
Well, that's what I was thinking. This is another one of those name collision places. I think what they're specifically talking about is if this is a point of sale application, the touchscreen computer at your grocery store, restaurant, whatever. I think that's because there's a lot of times we think, well, that is PCI, but there's a lot of applications that are included in the PCI space that don't have anything to do with that actual point of sale perspective, whether it's a web application or, a phone bank, where they're taking your credit cards over the phone and putting it in system, stuff like that.
Oh, people still give out their credit cards over the phone?
Oh, yeah.
I just brought up the purpose and scope because I have the document in front of me. So yeah, terminals in reference to what they call POI devices, which is
POI would be
interaction.
Yeah,
point of interaction. But that it also has a disclaimer. Well, not a disclaimer, but it looks like there's an exclusion to firmware of firmware specifically. So we're talking about software.
Yeah. So
aspects of POI.
I've got one around here somewhere. If you have we used to call them pin pads. Now they're pin transaction devices or stuff like that. The device itself will have firmware on it that handles all the encryption stuff and all the communications and all that kind of stuff. But then usually merchants can build their own application that says prompt this user for this, ask them if they want to buy a car wash, also ask them if they want to round up to give money to somebody's pet dog or whatever. That is a customizable application that you can build and put on there. So I think that's where some of that terminal software requirements would fall into play.
Yeah,
if you're using those types of devices. But for this for our conversation, module C is a little bit more interesting.
I like module C.
You want to summarize what's in there?
Yeah, well, so we've got the headers there, right? Components and services deals with a lot of that is going to be your open source bits or your purchased third-party bits that you're using. I
think it specifically mentions SBOMs, right?
Oh, huge. SBOMs are the bulk of what that section deals with. Is yes, you need to have one.
What's an SBOM? It sounds dangerous.
It is a software bill of materials. So all the things that make up your application that you're pulling in from third party places, and that includes transient dependencies. So it's not just the things you depend on directly; it's the things they depend on, the things those depend on, the things those depend on, and recursing down a long tree a lot of the time.
Like LeftPad.
Yeah.
You guys don't remember LeftPad? Oh man! So 3 or 4 years ago, LeftPad was the NPM module that some guy got upset because his account name was taken, and so he
you did a talk on this one.
Yeah, he delisted LeftPad from NPM, right?
Yeah.
And it broke the internet. Like Yahoo was down, Fox News was down, Netflix was down, because they all had these automated build cycles that just pulled in those dependencies and pushed it out. And as soon as one of those modules was gone, that long tree of dependencies that Mick was talking about, it just broke them all.
Yeah.
And it's hilarious. And it was a stupid module that basically just padded the left side of a string value.
Yeah.
That should be a line of code. There's no reason we need a module for that. But
Should have been in the standard library.
Exactly.
Nonsense. NPM doesn't have a lot of security issues.
But I think those types of things are why this is here, right? Because modern applications aren't built.
I don't remember which package it was, but there was another one where the open source maintainer just decided he wasn't maintaining it anymore. Okay. And he turned over the GitHub repo to somebody who volunteered to take over the thing, and they slid some malicious stuff in there and pushed a new release.
Yeah.
Yeah.
I have often said that if I was put in charge of maintaining the red team operations for a nation state, like external facing red team, right? Not, basically the attackers. One of the first things I would do is go to all of those little developers working in their basement. They've been maintaining small packages for, 10 years. And I would set up a legitimate company building software. And I would say, hey, thanks for all you've done for the last decade. Here's $50,000. We're going to maintain this for you and put all the effort into it that you've always wanted to, but haven't had time. And you just build a repo of like control over all of these little libraries.
All you have to do is turn over the keys.
Yeah. And you don't have to do anything malicious at that point. But when you're ready, when you're all of a sudden in the middle of some type of adversarial situation, now you have the capabilities of pushing malicious code to thousands of libraries.
I feel like you've thought this through way too much.
I don't.
Let me include my email in case somebody wants to, reach out. That would be a fun job. Being put in charge of nation state resources and just say, go attack the world.
Would it be fun? I don't know. Yeah. The thing that gets me with the SBOM stuff, the thing I don't know, because vendors have caught on, okay, there's a big need for this. And so companies like JFrog, who's known for Artifactory, they've got X-Ray out there, which is an SBOM generator. Because another one of the requirements in here is when you do a new build, you need an updated SBOM. Like it needs to happen.
Yeah.
So what most people are going to want to do is do an automated SBOM generator in their build tool chain. But the ones that worry me are when you have packages that do bindings to binaries. And so if you've got like an NPM package, a node package, but it's using C bindings to use a C binary under the hood, are the libraries that are being bundled up into that, or a Go binary would be a great example because it's all the, bundle everything into a single binary. Are those documented? Because then you're going from, hey, I can look in my package file and see what I've pulled in, to I probably can't. It's probably going to have gaps.
That's a good point. Is that similar to the way Java does, binds in the different libraries?
Yeah, Java's different. Java's a little more fractured, actually, as an ecosystem, because you've got Maven has really emerged, I think, is the most widely used, but people use Gradle for package management as well. And SBT you can use is developed for Scala, but you can use it with Java apps as well.
But in those cases though, you still have like trying to reverse engineer that to figure out, okay, what's in it, or what does it depend on, is I think a little bit easier with
unzip your jars
with Java, because you have multiple options. Yeah. So one of them is if your build process is using one of the build standards that you just mentioned, Maven or Gradle, and there's actually a couple of others out there too that are less common.
Yeah.
So if it's using one of those, then you can actually build that list off of the what do you call it? I'm blanking on the term now, but it's
POM file.
Yeah, a POM file or manifest. That's the word I was looking for. So you have a manifest type file that tells you, hey, this is all the things that are in here. So it's pretty easy to reverse engineer and figure out what's in there. But you can also, like you said, you if you really need to, you can pull apart a
jar.
jar file and look inside of it and see what's there.
What are you doing in here?
So,
Yeah.
unless it's all been obfuscated, because that is an option too. If it hasn't, then it's not that hard to figure out what's in there, which packages and that sort of thing. And there's typically an additional manifest information inside the jar file as well that you can leverage.
Back in my day, we just download the jar file off the internet and shove it into the class path.
Node and Python are similar as well in that they have basically package manifests.
Yep.
That will list all their dependencies.
Rust as well. Rust has got the cargo.
Rust as well. So it's fairly common across most languages to be able to do that. So as long as you have access to the build environment,
Mm-hmm.
and you're not looking at just the end binary, you usually have a pretty good way of automating that.
I feel like this whole process is like in 4 or 5 years, it's all going to be standardized and automated, and like all the different frameworks will use a fairly standard process to report that stuff.
Yeah.
We're kind of at the top of the commoditization process now, where we're still trying to figure out what's the best way to do it, and there's different competing ideas.
A few different standards for how to publish the SBOM as well. I think 3 main standards there. We don't do a lot of work with SBOMs. But.
Right. I did think it was interesting. When I first looked through this module, I was like, wait a minute, all of this stuff is already covered in the core requirements, right? Because we have asset identification and asset protection, like that's basically components and services. We have authentication and access control. Well, that's access. It literally says access control.
Yeah.
We have attack mitigation. On the other side, we have attack detection, and we have threat and vulnerability management. We've got communications. In the core requirements, we've got at least use of cryptography. So I guess the question that I have is why do you think this is significantly different that they made a separate module for it?
I think it goes into a lot more depth than the core requirements do.
Okay.
And a lot more specific examples in there. And I like the attack mitigation one here. And specifically, I think it's one of the first control requirements there. It mentions security headers, and it specifically calls out CSP in there.
Nice. Which
we saw people struggling to adopt for years, and still a lot of the times it's there, but it's not effective at a lot because it's just been loosened to the point where it just isn't helpful.
Yeah.
But it was interesting that they actually have that specifically listed under the attack mitigation under the security headers.
That makes sense, I guess. If you're building a non-web application, having sections about
HTTP controls.
Yeah, you're like, all right, I can mark not applicable, but that makes my document really, really long. Yeah. Whereas if I just say none of this applies to me,
skip the module completely.
We have sort of a set of baseline requirements. There are core requirements, and then an expansion on those for web software.
Yeah. I'm surprised there's not similar requirements for what do you call like a typical compiled application, right? Like if I write something in C or C++, compile a binary, there are similar types of things that I should and shouldn't do. I'm surprised they don't have a separate module for that type of thing. But maybe in
the future.
Yeah.
I mean, so if you're thinking like a desktop app that's isolated on a system, that's one thing. As soon as it's connecting to web services to do its work, then a lot of this web software stuff really should come into play as well.
Yeah. I know, going back to what I said earlier when I kind of summarized the PCI side of it, the PCI Council, basically what they do is they kind of follow hey, here's the next biggest thing that's creating risk for the card brands. Let's address that. And then once they've got a kind of good handle on that, all right, here's the next big thing, right? And so it started with merchant networks, and then they added in payment applications, and then PIN devices. They created a standard for third-party resellers, and there's a little foray into e-commerce specific stuff for a while. Like they just kind of go down the chain of what is the next biggest risky thing. And so that might be as part of the development process. It's like, hey, here are the most important things. Maybe these other issues aren't as big of a deal, so they just haven't put the time into it yet.
Yeah, just haven't come up, haven't floated to the top yet.
Yeah.
One of the interesting things that was living under the access controls in there that I spotted was it dealing with authentication specifically. It calls out like third-party authentication providers.
Okay.
So like Okta, Auth0. I would, from the way it's written, I would think that using cloud-based services built into cloud platforms, stuff like AWS Cognito would also fall into that category. But it is the wording around it, and I don't have it verbatim in front of me, but it is essentially to the effect of that they should be industry accepted, trustworthy third-party identity providers, basically. So your assessor could look at which identity provider you're using and go, that's not a trustworthy one.
I've never heard of them before.
Yeah.
Interesting.
Yeah, that's
I didn't realize that that it was stated like that in there. But
so one of the strengths and weaknesses of PCI with the auditor setup is that there is somebody that can make a definitive statement. This is good enough or that's not good enough, right? That on the network side, it's a QSA. When it was the PA-DSS, they had a PA-QSA. I can't remember the acronym for the Software Security Framework assessor, but something similar. Whoever your assessor is, they have the authority to say, boom, that checks out, I'll sign off on it. The downside of that is you're at their whim. Whatever they say, you have to deal with. But compare that to like NIST or HIPAA or SOX or whatever, any of the other requirements out there, CIS control, like there's no authoritative person that can say, yes, that's good enough, right? You're kind of on your own. And then the court decides later whether or not it was good enough after there's been a breach.
With the way a lot of this stuff in the module is written is really going to come down to that person's opinion too, because a lot of it is kind of vague in the sense that it is must follow industry standards and best practices type of phrasing.
Okay.
Where sometimes there are clear standards, but in a lot of cases there is, which standards? There are competing standards. They're actually opposing views in the space, things like that.
I think from our experience working with organizations, a lot of times you can tell the difference between the companies that have at least thought about why they're doing something and the ones that haven't, right?
Yeah.
And the ones that have at least put some effort into it, even if we may disagree on the specifics, they're still going to be significantly better off and more secure than those that aren't even looking at it.
Yeah.
So we talked a little bit about some of the other standards there. Our last slide here, we've got some of the others. I don't know if it's worth touching on these strengths, weaknesses. There's a lot of stuff out there.
Well, I think these standards serve slightly different purposes each, so we could go over that.
Yeah.
NIST is more generalized across the board type of stuff, right?
Yeah.
And NIST is more of a category. I mean, NIST is an organization that has a lot of standards, so
they do. I think in most cases, it's the 853 is what people are using and think of.
But 853 is huge. So
it's huge. It's huge. We have a client comes to mind though that we've worked with them many years on an annual basis. And I remember 3 or 4 years ago, they were picking specific control categories and working toward aligning with what was laid out in the NIST 853. And it was like 2 categories the first year, and then it was a few more the next year and so on. But we've seen the benefits of that work. That's a client that's got at this point, very mature security model that has come together for them across the organization.
So you have NIST, and then you have OWASP, ASVS, and OWASP SAM.
Yeah.
So ASVS is the Application Security Verification Standard, right?
Yep.
That one I'm very familiar. It's almost like an audit document. I mean, it's very similar to some of the PCI stuff in that it's very long and very.
Yeah. I've seen it described as basically a tool for measuring and comparing the security between products, which I think is not pardon me, is not unfair.
Yeah.
And then SAM is the software assurance maturity model, which for me that aligns kind of more closely with the both the Microsoft SDL, which is next on the list, and the SSF stuff we've talked about today as well.
The life
The life cycle side of it, right?
Yes, the life cycle side is a lot of practices that you should have, basically.
So more governance and operational practices, whereas ESVS is more about the actual software itself. So it aligns a little closer to the.
Yeah, so SAM groups them under business functions, and governance is actually the first one of those. Is governance, construction, verification, deployment. Yeah.
I know CIS is well known for the 18 critical security controls.
Used to be 20.
Yeah, it used to be 20, and then they kind of
consolidated.
Well, I know they consolidated software and hardware inventory into one. Yeah. I don't know which other one went away. It's been a while since I've looked at that.
Yeah, I can't remember now. Yeah,
but I know one of the controls is specific to maintaining application security. But are there other guidelines? I'm not familiar with anything else from them. Like, they don't have other documents and standards, do they?
Well, I mean, they've got definitely the benchmarks for different solutions.
That's right. I forgot about those.
The CIS benchmarks, which are really good, like how-to guides for things.
Yeah. So that's not so much a standard as much as a, like, here's how to compare how you're doing.
Yeah, you're a lot of the time it's configuration. The ones I've used anyway, the ones I've looked at.
A lot of them are configuration, and a lot of them are pretty useful. I mean, we've gone through and used like there's one for AWS accounts. I don't know if, like, we looked at it a few years ago, so I don't know how much has changed now, but what sort of security controls or things can you implement in there? And in many cases, it isn't a throw this big expensive tool at your problem. It's here's the steps to configure things or build your own scripts or do like things that you can do at a lower price point yourself.
I know I have seen cases though where, particularly with Microsoft SaaS solutions, where the license tier does end up being a big factor in which options they can actually take advantage of.
Implement.
Implement.
I know John and I did an ARC review for a client over the summer that we used they had a bunch of stuff in Azure, and then they had some on-prem systems. And so we went through and used the CIS benchmarks to, validate how they were performing against those. Yeah. So, and then of course the OWASP proactive controls. I'm a big fan of that list.
I like that list, but I don't know. Has it been updated recently?
2018, I think.
Yeah. That's the challenge with a lot of this stuff. Like, CIS is a non-profit org, but they're really well funded, and they put a lot of effort into maintaining their stuff. Microsoft obviously is a corporate organization. NIST has the government backing, but OWASP kind of struggles on that because they depend so much on voluntary stuff, and there aren't funding, or at least they haven't figured out the funding yet.
It's kind of a collection of open source projects, or they behave like it.
Right.
I know when I was digging around in some of these, another one came up called OWASP CLASP. Do either of you remember this?
I remember hearing the acronym. I can't remember what it was for.
Yeah. So comprehensive, lightweight application security process. So it seems like it would have met this list. We would have put it on this list.
Yeah.
But everything I'm finding on it is old archive stuff from like 2006. So
2007. That's the latest I see.
The project just that particular iteration isn't alive anymore. I don't know if some of it got rolled into SAM, but the SDL, because we kind of jumped over it, there's a lot of good stuff there too. It's kind of, again, a bunch of practices. So basically a list of practices. It starts, number one on there is provide security training, right? And it builds out right through to running SaaS and DAS and having pen tests and all that sort of stuff. But they've got a whole bunch of resources kind of consolidated in one place for it. So
yeah,
nice.
Makes sense.
Cool. Well, I am not seeing any questions, so I think we can go ahead and wrap it up here. If you do have questions, you can reach out to us, education@securityds.com. If you're attending the live session here, you can also get a CPE. If you need the document for that, just let us know.
Or join our Professional Evil Slack channel and ask us questions there.
Yeah, absolutely. If professionallyevil.com, right? And down towards the bottom, there's a link.
An invite right there. Yeah.
Yeah. So we would love to help you out any way we can.
So that's it. This ends our session on improving application security with the PCI Software Security Framework. So
you got all the words.
It's a very long title.
I'm sorry. I wrote that title and I think I managed to get through the whole thing without saying it.